All right, today we're going to talk about three forms of a quadratic. So this one is the first form, standard. So let me see if I can highlight that. So standard form looks like this. Okay, f of x is equal to ax squared plus bx plus c. So what does that mean? All these three examples right here are written in standard form. Okay, and what I'm going to do is I'm going to label these. We're going to say this is the first equation, second, and third, just so we know what we're looking for. So anytime an equation is written in this form, there's something that we can pull from that equation really quick. Okay, and so that's what I'm going to highlight. We're not going to fill out everything down here in these boxes. And we're going to imagine like we don't have access to these graphs right now. So what can I see out of these equations right now? So if something's written in standard form, okay, and I'm going to label this, the concavity deals with the a value. So when I'm looking at these equations, what I'm looking for is the value of a. So here it's just the number in front of the x squared term. Okay, so for the first equation, a is equal to -5. In the second equation, a is equal to 1. And then in the third equation, a is equal to 1/2. And so in that equation, I can look at that term or that coefficient attached to the x squared term, and that's my value of a. Now, what can I get from that value? If the a value is positive, then it should open up. So here for number 2 and 3, both of those values are positive. So this parabola, both of these should open up. Since number 1 is negative, so it's a -5, then that means it's going to open down. So we check that, right? So we now have we can look at our graphs, and in fact, 2 and 3 open up, and number 1 opens down. But we can know that without having to put this into the calculator or Desmos and actually visually see the graph. We can just tell that by the equation from the a value. Okay, so that's the first thing that we can identify from standard form. The second thing we can identify from standard form is the y-intercept. Okay, and so again, I have these labeled 1, 2, and 3. And so I am going to look at my graph, and I can see that the y-intercept is there. And this one, it's kind of hard to tell right there. And then here, somewhere right there. Okay, so this is what I want you guys to understand. This y-intercept is at 0, 21 actually. Okay, but here is the value of my y-intercept. Right here, it's at a little bit below 0. Well, -1 is my y-intercept. And then this one's a little bit above 5, which is 5.5. That's my y-intercept. So my y-intercepts from looking at standard forms is just the constant number, that last number right here. And we're going to actually write this as an ordered pair. So 0, 21 for number 1, 0, -1 for number 2, and then 0, 5.5 for number 3. Okay, and so those are the key characteristics that I can look at standard form, just the equation only, and pull out. Okay. Now, moving on to our next form, factored form. Okay, factored form, again, looks like this. Okay, it's just like we were to factor something, right? We have roots or x-intercepts and whatnot. Again, I'm going to label these 1, 2, and 3. And again, for right now, we're going to imagine like we don't have the graphs. Okay, and so if something's written in factored form, again, I can figure out the concavity. just by looking at the value of A. So I'm circling the value of A in all three equations. So for number 1, A equals a positive 2, which means that should open up. Again, I would not need to graph this to understand that. I can just pull that from my equation. In number 2, A is equal to negative 2.5. So negative tells me it's going to open down. And then number 3, A is equal to 1/2. So that also opens up. So again, from factor form, we can pull out the A value. Okay. The other key characteristic that factored form has are factors. Okay, so for number 1, number 2, and number 3, I'm going to look at our roots basically, which are also our factors. So our roots right here are going to stem from this value here. Okay, and so what happens is, remember, anything inside parentheses is going to come out to its opposite. Okay, so for instance, now I'm looking at the graphs just to prove my point. This has an x plus 1, but our root is actually at -1. And this has x plus 5, and our root or x-intercept is actually at -5. So since it's inside the parentheses here, when we write our roots, they're going to turn to the opposite. So for number 1, our two x-intercepts, or our two roots, -5 and -1. Okay, for number 2, notice it's the exact same thing twice. So we're just going to write it one time, because you can see on the graph, it's only got the one root. So that's just because it was x minus 3 and x minus 3. Both of these are going to be positive. You don't need to repeat the same number. Okay, and then in number 3, this is x plus 5. So that becomes a -5. And then this is x minus 1. So that becomes a positive 1. And again, I use the little squiggly brackets to say that both of these values are x-intercepts. So I have two x-intercepts in number 1, one x-intercept in number 2, and then 2 more in number 3. Okay, those are the two main characteristics you can see from the equations. Okay, I can also use my x-intercepts to help me find the axis of symmetry for factored form. Okay, and this is how I do it. So remember, the axis of symmetry is going to be an equation. So these have to be x equals. And then what I'm going to do is I'm just going to find the average of these two. So the average of -5 and -1, and I divide that by 2. So -5 with -1 is -6, divided by 2 gives us a -3. So the axis of symmetry is x equals -3. Since there's only one intercept for number 2, then that's my axis of symmetry. And then for number 3, again, I find the average, this time -5 with a +1. So that gives me -4 divided by 2, which gives me -2. If I wanted to double check myself, we can come back and look at the graphs. In number 1, it does in fact go through -3, so we're good there. In number 2, the axis of symmetry does in fact go through +3. And then in number 3, the axis of symmetry goes through the -2. Okay. So those are the 3 characteristics you can find from something written in factored form. And then the last form of a quadratic is our vertex form. Okay, hopefully you guys can kind of see the pattern. We're going to be able to see our vertex from our equation. So again, same thing that we started with all these. We can always see the concavity of these. So A is just always that first value. And in number 1, we just have a negative, so that's actually a -1. So that's going to open down. In number 2 right here, sorry, I forgot to label these. in number 2, there is not a number written right here in the front, so we assume that is a 1. Okay, and so it opens up. Same thing for number 3. A is 1. It should also open up. Vertex form should look familiar. All it is basically it's written like a transformation. Okay, so if it looks familiar to you, it's because it's kind of written exactly how we would write our transformation as well. Okay, so we know the concavity, and then we should know the vertex from our equation. Again, everything today is, can I identify what form it's written in, the equation, and then what can I pull out of that equation without having to graph it. And so for number 1, the vertex is going to stem from these 2 values. Okay, remember what happens when something's inside parentheses. That's x plus 2. So it's actually going to move to the left 2. So that gives me a value of negative 2. And then this value just stays what it is, minus 4. And then for number 2, again, x minus 4 becomes a positive 4. We keep the negative 2. And then for the last one, number 3, x minus 1 becomes a positive 1. And then there is no value written over here. And so that value is 0. Okay. And then the last key characteristic out of vertex form is obviously if I know the vertex, then we talked about this last class, I should know my axis of symmetry, okay, because it's going to be the exact same as those x values. So we have to have x equals again. So for number 1, x equals negative 2. Number 2 is x equals 4. And number 3 is x equals 1. And so those are the key characteristics from each type of equation. And all 3 of these equations, again, represent a quadratic function.